would like to show you how to track individual particles using Trackmate. So for this, Trackmate is a Fiji plugin. So we open up Fiji and we import our TIFF stack. I have here in the recent history. So this is my TIFF stack, which is from a spinning disk confocal, fluorescent particles moving around. And before we go into Trackmate, I just want to show another option to visualize particle trajectories. That is by forming a Z project. Oops. So we go into Image, Stacks, Z project, and we look at the standard deviation, which I find is quite useful to highlight the individual points per frame with a high contrast. And what we get is like a projected view of the particle movement, which I think is quite useful. Like that. So you can see that the particles sort of move in this snake-like way across the time. If we also want to have a time information in this projection, we can encode this into a color code. We go into Image, Hyperstacks, and Temporal Color Code. Here, the lookup table thermal I find quite useful. We do this for all frames, maximum projection, and we want to create a time color scale bar. So now we get basically the same type of projection, but now each point has a color code depending on the frame where it appeared. So now you can see that the color changes from blue to red. So these particles move from blue to red. So now you know how the particle moved in time. So I find this quite useful. Okay, let's look at Trackmate. Next, so Trackmate is a pre-installed, I think, plugin in Fiji. We go to Plugins, Tracking, and then Trackmate. And everything I show you for Trackmate and also later for the post-processing of the Trackmate trajectories is very well described in this book chapter, which I would recommend and also link in the description of this video. So everything, also the details of all the different options in Trackmate, which I will not mention in the video, is described in this book chapter. Okay, so we have our TIFF stack, we have open Trackmate. On the first window, we can select the region that we want to work on. In this case, I want to analyze the entire window, so I don't put in a ROI here. You can simply add a rectangle and then refresh the ROI to only work on that particular window, but I don't do this here. So the first step of tracking is usually to detect the particles. Since we have only the TIFF stacks for now, Trackmate has a couple of different detection algorithms. So I use this LOG tracker, LOG detector, and again, these are all described in this book chapter. On the next window, we have a couple of parameters to choose on how the detector performs on that image. So the size of the object it should find. Of course, we don't want to find pixels, we want to find objects. So we have to choose a minimum size and then also some sort of quality threshold. We can look at the preview here. I think this already looks quite fine. So it finds the big blobs, it also finds the smaller ones. Some of them are maybe a bit too small, but those we can filter out later. So we go to the next window. If we are happy with that preview, it will track all the particles and give us sort of a summary. Then based on the particles, we can already sort of filter out some that are maybe not good enough using the quality parameter. I usually keep this at maximum to select all of the particles and then filter out the low intensity ones later, but you might as well do this already here. So here I use, for example, the mean intensity for each particle per frame as a quite nice filter. So if I play around with this and you pay attention to the circles here around the molecule candidates, you can see that if I move the filter to the right towards the higher intensities, we get rid of the low intensity guys. So here, for example, these spots here, which are hardly any molecules are visible, we can get rid of those by just moving this threshold a bit towards higher mean intensity values. So I think this is quite nice. You can also select other filter parameters like contrast frame and so on if you want to move, if you want to ignore a couple of frames in the beginning or at the end or something like that, whatever. I think the intensity is quite nice already now. So after detection and filtering, the next step would be to link the particles. And here again, Trackmate comes with a couple of different trackers. I use in my case the lab tracker, which works quite well. And then we have these linking options. So first we want to decide how far the particles can move between frames. So I choose this to be one frame, which depends of course on the frequency of the acquisition, and if the particles can disappear. So in my case, I allow gap closing so the particle can dive up or down or be not detected in one frame and still be connected to a previous trajectory if it's only one frame and the particle did not move further away than 2 microns in this case. Okay, so we go further. This also needs to be tested and optimized on the particular data set. Okay, so now we get again a summary of the trajectories. We can also see them now on top of the image. We can also browse through the acquisition and see if the particles sort of are detected and move along the trajectory as we would, see them by eye, and I think it looks quite nice already. Okay, we go to the next window. Now we can filter the trajectories as well. For example, there's again many different filter parameters. I think the duration is quite nice. Speed, direction, and length, and so on. So I think duration is quite good. So we don't want to look at some sort of micro trajectory. So we only choose the ones that have a certain minimum length. So this is a bit arbitrary. I think I just put it here somewhere. Yeah, it's very close to the suggested value. Again, there's other filtering options here. And then we have some output options. So we can modify the visualization here by changing the spot size, for example, or how the spots are represented, how the tracks are represented, and so on. And we can export that if we want later on. We can already now here export the tracks and the spots as sort of a new window that you can copy and paste into a new application. We can look at a couple of features using this plotting function. For example, we can plot the time against the mean intensity of the particle, to see if the intensity sort of has some, if there's any bleaching, or if the particles dive up and down or disappear, or something else happens during the acquisition, which is quite nice. And as a last step, of course, I skipped over many different options and parameters that are available in Trackmate. But I just want to jump directly from the particles now to the export option, so we can capture that overlay, which is this video of the labeled particles and trajectories, which is nice maybe for a presentation or so. And then usually there's a couple of different export options. The one I use and I will present in another video is this XML file. So I choose export tracks to XML, which can then be opened using another application and processed further. So we can say execute and save that XML file, and we are done. And we can open this XML file in another software and start post-processing the trajectories.